Hello, everyone. Welcome to Cloud Native Live, where we dive into the code behind Cloud Native. My name is Taylor Dolezal, and I'm head of ecosystem at the CNCF, where I get to work closely with teams as they navigate their cloud native journeys. Now, every week we bring a new set of presenters to showcase how to work with cloud native technologies. They will build things, they will break things, and they will answer your questions. In today's session, we have Pierre Tessier from Honeycomb, and today Pierre will be presenting the OpenTelemetry community demo. I'm really excited to see all of the things that come out of the OpenTelemetry demo today myself personally. This is an official live stream of the CNCF, and as such, is subject to the CNCF Code of Conduct. Please don't add anything to the chat or questions that would be in violation of that Code of Conduct. Basically, please be respectful to all of your fellow participants and presenters. Be excellent to one another. With that, I'd love to hand it over to Pierre to kick off today's presentation. And with that, Pierre, please take it away.
Awesome. Thank you very much, Taylor. My name is Pierre, Pierre Tessier at Honeycomb.io. I'm really excited to talk about this topic coming here today. It's something that's been consuming much of my free time and just a lot of thoughts and process for the past several months, but it's coming to fruition. It's coming to fruition really nicely. I'm going to talk about the state of today, so early October 2022. I'm going to talk about where we're going with this and what's happening with the OpenTelemetry demo itself. If you have not heard about it before, well, what is this thing? It's really a showcase of everything OpenTelemetry has to offer for the community out there. How to use it, where to use it properly, different combinations of usages you could get out of it. What we did is we took a 12 microservice application written across 10 different languages, and we're going to show you how to deploy this thing, how it's instrumented. It's meant to be vendored and forked, if you will. There's a lot of vendors that are part of the OpenTelemetry community. That's what helps keeps it going. We have employers that are grateful to provide us with the way to contribute code for the wider community to use. Well, these vendors also want to show off what they can do with OpenTelemetry. And this demo is meant to be forked so they can do exactly that. We do have our own GitHub repo, of course we do. It's like all OpenTelemetry SIGs. Go ahead and check it out. And we'll check on that a little bit more later. But I want to showcase what this thing really is. It's looks like this. It's like I said, it's got 12 different services in here, a couple different storage locations as well. It uses Redis, which we don't count as one of the services, and also a PostgreSDB, again, not counted. And I'm mistaken, actually, I mean, it's 13 services. I keep on saying 12 because I don't count the load generator as a service per se, but it is in this case here. So if you look at all the boxes, you'll count 13 up coming up here. Internet should not count either. Neither does load generator if you want to get to your 12. But and we've written across all these languages. The only ones that kind of duplicated is front end and payment on JavaScript. But it's fun. Front end's actually written in TypeScript, and payment is written in JavaScript. So although it's written in the same kind of output compiled, if you will, runtime interpreted language, they do showcase a little bit of the syntax differences between the two. I also want to mention front end also instruments the web browser. So if you came in here as a front end developer, like, man, I really wanted to insert the web browser, I got you covered. We're going to show how we do this later on today. And then we move on to the other languages across the whole gamut. Notably missing here is Swift. We do one day want to add a Swift client to this application to make it even better. And we're also going to be looking for a host to provide this application for people to use without having to install it as well. So that's coming soon. Plans for that to be determined. If you want to help out here, I'll get more info on how you can reach out to us and do exactly that. And with that, who am I really? I work for Honeycomb.io. I run the solution architects team over there. That's a team of people who are passionate about ensuring that other customers instrument their code, get up and running, mostly with OpenTelemetry, and get the observability they need for their applications. At Honeycomb.io, we are very much committed to supporting OpenTelemetry, and we support all the various endpoints for it to receive traces, metrics, and logs into our platform, allow you to provide what you need to do to debug applications should they go sour in production. or maybe you just want to find performance improvements. So we help you do that. And also, I'm a maintainer on the OpenTelemetry SIG itself. I've been part of the SIG since it started, and really happy to be part of that and do the contributions that we do. I'm going to dive into some details on what the demo itself does. Maybe some interesting stats as well to help you understand. First, a little bit of history. The SIG was formed April 26th this year. We had our first meeting on May 2nd. And, I think Carter might be watching right now. Carter from Microsoft, he's been instrumental in really kind of kicking us off and getting it going and helping us move this project along and meeting our dates. And most importantly here, we're going to hit, I'm very confident, we're going to release GA at the end of this month, the week of Cloud Native Con, KubeCon. So on that Monday, we're going to have a GA release ready for everybody. It's going to be less than 6 months since the SIG's inception. So I don't know if that's kind of a record or not out there, but we're really proud of the work we've done. We did have a massive initial contribution, thanks to another one of our contributors, Giuliano, who took the Google Cloud project. It was known as Microservices Demo. People knew it as Hipster Shop or Online Boutique. He took that and kind of ripped out all the old instrumentation, all the other stuff, and got us a first cut of this running with OpenTelemetry so we could use. But we took that, we refined it, we made it idiomatic, and ultimately we're going to be releasing 1.0 here shortly. The goals we wanted to do here was we really wanted to have a common demo that can be used by everyone in the OpenTelemetry community. It wasn't just vendors, it was people and other developers that were spinning up these little mini Hello World applications, or maybe they were using some other applications or some other microservices things, and it was getting kind of just fragmented out there, and they were doing it a little bit differently. OpenTelemetry is a very evolving stack of technologies, right? It spans multiple languages, and they're all kind of evolving at their own pace. Sometimes they change how you should do things, and all these demos were not necessarily keeping up. So we wanted to create something that kept up with the latest and was common across them all. And we wanted to make sure it includes every single language that OpenTelemetry has support for. We're one short right now, Swift. We will get there, but we do support the entire ecosystem. It's got to be using the latest stuff. Like I said earlier, it's really important we do that. And I think the biggest point here that everybody should appreciate, it needs to be well documented. People need to be able to just go to this thing, look at the code, look at the docs with that code, and understand how to do it themselves. We need to enable the community with this demo. And how you do that is with good, strong documentation. And that's really one of our big goals that we're going to do when we release eventually. A couple of stats, and I really caveated this with as of this morning. The repo's got 150 stars, 95 forks, and 34 awesome contributors. We just cut release 5-0 or 5.0-alpha yesterday. It says alpha. I don't know. Maybe we're ready to drop that label and call it beta, as we now have all services ready and kind of nearing feature freeze here. You can use it. It works. I'm going to show you the small little caveats of deploying this thing later on in the session. It works across the whole gamut. So definitely don't be scared of that alpha label right now. If you're interested, and after you see all this, you're like, wow, I want to help. We do SIGs. We meet every Monday at 8:15 a.m. Pacific time. Again, the repo link, we do have our own Slack channel. OTel Community Demo is a Slack channel. In case you haven't figured it out yet, we're looking for Swift developers. We want to do this. We don't have anybody well experienced in this. And we're really looking for perhaps a Swift developer who can help us do this, build us a small app. Let's get it in the App Store, and let's allow people to actually play with this, and we'll have them point to a hosted version of the demo itself, and it'll be great. People can actually use their phone and work with this demo and see the code, how it all works. So if you're interested in the right Swift code, please reach out to us. We're happy to help and provide you whatever support you need to get going. Now with that, what did we do in the code? What did we actually instrument? So first off, when we did this instrumentation, We really wanted this to be in an idiomatic way for every single language, and that was really important for us. Um, it's just we want to make sure that when people look at the code inside this demo, that's the right way to do it. If you were to go to OpenTelemetry docs and you were to go to copy and paste code, it should drop right into what we have inside our demo. That's the idea. And as the SDKs evolve, as they perhaps add additional APIs and functionalities to allow you to tie in and make it easier to use, we're going to update the demo code to stay in conjunction with whatever is available in the rest of the OpenTelemetry community. And this will be the proper way to instrument. And we're going to keep on doing that. So you can be rest assured that what you see in this demo will be, hopefully, will be how we want you to move forward with it and how to use OpenTelemetry to the best advantage. I see here a link. Somebody's asking for that link in chat for the repo. I'm going to post it there in a couple minutes. Just give me a couple seconds and we're going to run through more stuff, and I'll make sure I get you all the links when we get going for the repo itself. Sorry, here we go. So what did we instrument? Well, for traces, all languages support trace. So they all have tracing support. We do auto instrumentation where available. So Java, Python. Node is kind of a weird thing. People call it auto instrumentation, people don't. I don't know where you want to sit on that world, but we did it. Okay, it's pretty easy to do with Node. And all languages also have manual spans. They will all have manual span attributes. Almost all languages have services have span events. Actually, I believe all services do span events somewhere there. Maybe Elixir might be the only one we don't do that for. I'll have to double check. And we also included span links. And we only did this for one spot, notably in the front end. But we wanted to introduce a concept and why you would need to use a span link to make sure people understood why we kind of did that. For metrics, we're going to have Java, Go, and .NET with our GA release is the goal. We have a stretch goal to also include Python, though we're a little dependent on that SDK for us there. So like I said, we're keeping up with what the SDKs are doing for each language. And as they GA their support for metrics, we're going to go ahead and add that in as well. For all of these metrics, we're going to include the runtime metrics available to us. So like JVM, you get heap metrics, threads, and stuff like that. Go, you get like Go routines, I think. We're also going to include on the HTTP gRPC endpoints, we'll include all the latency distributions for every one of them, like kind of your typical things. And we're going to get this dumped into a Prometheus, another CNCF technology. So it'll go into Prometheus, and then we're going to be able to provide you with a Grafana dashboard to visualize it, all part of that same package. Traces are going to end up going to a Jaeger that gets deployed part of this demo as well. So you could use that. But like I said, because we made this very vendor fork friendly, it's easy for you to pipe your output to somewhere else. I'm at Honeycomb. I'm going to show you how to do it for Honeycomb, but look, it's the same process. If you want to dump it into Lightstep, or if you want to use Splunk's way of doing it, or even Datadog, or any of the other vendors, it's all going to be very similar in how you get the data out to them from this demo. Now, one more thing we wanted to add, and this is a tricky one, it's context propagation. It's important, very important tracing to do this. So all the trace headers will propagate properly. Kind of already do it for you out of the box. Some languages like Go, you got to explicitly configure it. But baggage. This is an often, well, not perhaps often, but it is a discussed topic. And even when we were discussing it in our SIG meetings, it turns out that a lot of people perhaps don't use baggage the way it's supposed to be used. And if you don't know what baggage is a way for you to pass at a telemetry level additional context, additional information about that request. Unfortunately, some people perhaps are using this to actually pass additional parameters to the request itself and use it downstream. And that's not the right use of baggage. You should be modifying your procedure calls instead. Pass that extra parameter properly when you're calling the various services. Don't attach it to your telemetry. What you attach in baggage should be context to affect your telemetry itself. So we use that, and in baggage, all requests coming from the load generator will be marked synthetic. And then we handle this later on in the front end to understand what to do with the trace. We actually break the trace up in the front end if it's a synthetic trace. We continue that baggage down to alert the rest of the downstream. But effectively what happens is the load generators have their own trace, and then we continue a brand new trace from the front end, linking back to that load generated trace. If you come in from the UI, the browser itself, that won't be an issue. You won't see that broken up stuff. You won't see the synthetic stuff at all. And we maybe don't do the baggage stuff. So proper use of baggage, kind of want to encourage people to don't use baggage to do things that you should be doing in your procedure call signatures instead. Use baggage to influence your telemetry. And that's what we want to do. Also, all metrics will include trace exemplars where appropriate, so you could use those in any platform that supports them. With that, let me check real quick here if there's any more questions here in the chat. I see, Taylor, thank you for dropping in the link to the repo in there. I see a question, which profile to use, engineer, DevOps? This is for all engineers, OpenTelemetry, QA engineers, DevOps, operators, developers, platform engineers, SREs. We all benefit from additional telemetry in our production apps. And OpenTelemetry is made to do that so that you could send it to whatever tooling you have to understand what's running in production. Doesn't even work. So one use case I like to use often with OpenTelemetry when it comes to distributed tracing in particular, and when you add the right context, is you can find those really gnarly bugs. I say this often, but things like maybe iOS version 14.1 using the French language pack located in Germany, and that for whatever reason has a problem loading the resources because last week somebody made a change to the resource loader. OpenTelemetry provides you the context, and if you have the right tooling in place, you could find those kinds of really gnarly bugs in your applications. So moving on, let's get talking about deploying the actual OpenTelemetry demo itself. So part of this, we wanted to make it really, really easy to deploy. It is a microservices application, so we got to think about how do you deploy a lot of things together. Naturally, we have two choices here when it comes to containerizing stuff. You have Docker and Kubernetes. We provide both avenues. There's a lot of services in here, so if you're just going to spin this up in Docker, you need to configure Docker to have at least 8 gigabytes of memory. You could probably get away with 6, but I don't recommend it. Give it memory. Okay, you're running 13 services. It's not a 13 plus Redis plus a Postgres. So really, you're running 15 containers plus an OpenTelemetry collector, 16 containers to make this thing work. Make sure you have the memory for it. It's simple. Git clone, cd into the folder, and then Docker compose up. If you do not pass in -- no build, this could take up and above 20 minutes to build. If you're building it all from source, it will take a while. It's working. It's just going to turn away for a while. Definitely something you want to run before you head out for lunch and come back. We provided a way where we give images. We publish images, so you can run this without having to go build the images yourself. Patch in the no build flag, and you'll get the latest images that we published to spin up. I want to also really strongly note here, this is Docker space compose, not Docker dash compose. Docker made a change in how compose works, and they're effectively deprecating Docker dash compose. Compose is now part of the Docker binary itself. Docker space compose. There are new features part of this that we take advantage of inside of this demo. So you have to use Docker space compose, otherwise that you may get an error. Docs matter, right? I said earlier, we're going to well document everything. There are documents about this as well within the actual repo itself. Under kind of the docs folder, you'll see a deployment for Docker there. We're going to do this in a little bit. I'm going to show it off how we're going to do it. We're also going to do this. This is really great. You need Helm 3.0. I don't know what version of Kubernetes you need. I'm sorry. I don't think we do anything special, so you could probably go way back in Kubernetes days and it'll still work, though you should be running a supported version at this point anyhow. Add the OpenTelemetry repo if you have not already done so, and it's Helm install. the actual demo itself, and its default settings will get it up and running for you. When the install is done, it'll give you a couple commands you could use to do kubectl proxy to port forward the right port so you can actually access the demo. Another option is you can mainly deploy ingress routes if you want to, so you could provide a way for you to access that demo through a web browser. The Helm chart does have several configuration options. There is also currently, as of right now, a very tiny bug in the Helm chart in that the email service will not export its spans by default. We're aware of it. We've just found it this morning. I'm confident the team will have a PR. We'll have that fixed shortly. I'm going to show you how to get around it today, but I'm going to guess by the end of this week it'll be resolved because we are pretty fast moving on this whole entire world. So I've done a lot of talking, a lot of theory, I guess. I'm done with my slides. This is not for me to talk to you about slides. It's for me to show you how to do this stuff and how to run it in code and take a look at it. Before I do that, if there's any kind of wild questions or anything like that, please drop them in the chat. I'll keep an eye on chat here moving forward. But let's go ahead and dive in to what this thing actually is. So first off, this is the repo for it. Right here, it's already been linked. From a kind of structure perspective, our README is really just that same service map you've seen earlier with the legend and links to, again, documentation. We're really all about the docs here. And all of these links are all contained within this docs folder up here. Inside of this docs folder, you got some screenshots. You got our deployment stuff. We're going to have feature flags in this. You might have seen the feature flag service running. The idea here is we're going to introduce some scenarios where they can break. Now, by default, the feature flags are all disabled. You have to actually go into the feature flag UI and enable them yourself, or perhaps modify a fork where you just enable it in your fork. Things that are coming out, you can understand them. Right now, we define 2 feature flags, although just one of them actually does anything. We're working on it. We'll get more. We're going to build up some more scenarios in here, some more breaking ways, if you will. If anybody's wondering, the feature flag service was written by Tristan, for those of you who know who he is in the community, and Elixir, of course, because that's what he's wonderful at. It's a pretty simple Phoenix application in Elixir, and it just serves up some flags and writes them through Ecto, I believe it's called, into a PostgreSDB. We're going to actually look at this UI here in a little bit. Other parts of this, of course, of the Docker deployment, talk about the Kubernetes deployment. And I like to talk about these 2 tables right here. I'm going to start off with the trace service features first off. I'm really proud of this table. We've actually accomplished all of our goals in terms of tracing coverage thus far, because we don't see any more construction signs anywhere on this table. We can't do certain things like for C++ and Rust, there are no instrumentation libraries, so we don't do those. And we just didn't do manual spans in this Go service down here because we did them in this Go service up there. It's kind of all those things are. And we'll talk about where the RPC context propagation doesn't exist for you, so you got to manually specify in Go and C++ again. And again, I mentioned where we do the span links as well as baggage stuff. And I'll show you how all that works later on. For metrics, the coverage is much lower right now. We're working on it as we speak. There are PRs available to get stuff of this done. I am actually looking at this table and it may be not quite as up to date. So we'll make sure we clean this up here moving forward. But that is our goals, to make all the construction signs go away, either replace them with completed, or we're just not going to do it for any particular reason. With that, I'm going to drop into the last one here, and we're going to do this for any manual tags as well. Part of this is you're going to add attributes, manual attributes. The thing about distributed tracing is that you get good value with automated instrumentation libraries and automatic trace instrumentation. But where you get a lot of value, where you go over that chasm and really benefit from it, is when you all add context from your application, which only you know as the developer. I believe there is an OTEP right now that should say all of your own context should be prefixed with app dot. We did that here in our demo. So every one of our attributes start with app dot. And although it may seem like it's app dot service name and an attribute name, that is not what it is. It's app dot context of what this thing is and where it comes from. And these are the ones that add service will add. These are the ones that cart service will add. So you see cart adds about product, app dot product dot ID. And that's kind of a schema that works well with many organizations. We would recommend you do the same thing for yours. And we just document what they all are. So when you're using this thing, and when you're searching for specific attributes, you know where they came from. And you know why we set them in there and what kind of values they will contain. So, done a lot. I've said a lot. I'm going to dive into a little bit of code right now and show how this thing works. So you can see how I stopped this just not too long ago. I'm actually run this in Docker compose no build. And that's it. I'm just going to run this. If you have not done this before, it'll go ahead and pull all those images down. So it'll take a few minutes for it to probably pull all your images, but then it's going to start up and you're going to be off to the races and running. There are various UIs that are made available to you for you to go click on and go explore what is going on in here. And when you run Docker Compose, we take care of exposing all those ports for you with the Docker Compose command. So what are those URLs, if you will? I've got them all bookmarked underneath my thing right here, but you know what? We documented them for you as well. And they're all available right here. Oh, I'm sorry, I went to the wrong spot. I want to go to my Docker deployment, and they're all going to be documented right here for you. Web store, Jaeger, Prometheus front end, the Grafana front end, the feature flags UI, the load generator UI. Yes, we put a UI in the load generator because Locus is great like that. It does it for you. So I've got this running, right? Let's go look at what it is first off. So I'm going to go to the demo app. I'm actually going to create a new tab here. And we're just going to go to the demo app. And this is it right here. It's if you've seen an online boutique from Google Cloud Project, it might seem a little familiar. And I want to say this front end has been rewritten. I want to call out to Oscar Reyes, who rewrote the entire front end in Next.js, gave it a gorgeous modern touch to it. It's now an SPA contributor now. He's part of our team. He's on all our SIG meetings. Really phenomenal, the work that was done here for this. He's also done other stuff for us to do integration testing, but I'm particularly really proud of this gorgeous looking UI we got here. You can see the OpenTelemetry inspired, products, if you will. I'm going to go ahead and just click on one of these. I'm going to add a chunk load of these. I'm Canadian, so let's go ahead and find the Canadian currency code. They're not super cheap. Add them to cart. You can see them. I'll make a $2,400 purchase. No big deal. I'm sure my significant will be okay with that. But we're off, and I've generated data inside of my environment. Now, at the same time, we're also generating data through a load generator. So I didn't need to do all that stuff. I could go ahead and go find my traces if I wanted to. But remember I said we're running a load generator. So we could go look, see that load generator UI. I'm just gonna go right into Jaeger right away and just show off, hey, okay, I got 13 services going on here. Here are all the various services you wanna look at. I'm just gonna pull up front end and I'm gonna look for particularly the place order endpoint. Place order hits a lot of services. It's probably the one route that does the most things throughout the entire thing. So go ahead and find traces on that. And you can see here, I've got 49 spans, 56 spans, depending on them. Some of them will place more products in there than others. And there you go. I've got my trace. It's all up there and running. And at the same time, I'm also sending this data to Honeycomb because I said, remember, this is meant to be vendored. So I'm going to show off what the vendoring looks like to make this happen in Honeycomb. And you might have been looking right here and you might have seen it earlier. Now, inside of every repo, I encourage, if you're a vendor, fork this thing right now. Go and fork it right away. Just fork that repo. Go inside of source, OTel collector. There's a file here called OTel config extras. I'm going to diff this file so you can see what I've done to it differently. And basically, it's the whole file. I've diffed it, okay? I've completely replaced the whole file. The idea here is this is any additional configuration you need to send this to Honeycomb. Yes, that is my API key right there. That's okay. I'm going to delete this API key when we're done. If you use it, it's going to send data to like a demo team that we have in Honeycomb. It's fine. But this is your configuration. So if you're a vendor, add in whatever it is that you need to do to send your data into it. Or if you're just wanting to build some cool stuff and you want to use it in your own little thing, go ahead and configure this. Make sure you add your exporters into the pipelines. Right now, we only have the metrics and traces pipelines defined, and you're done. And we'll merge that with the prior one. I do want to note that merging configs, maps, merge, arrays, overwrite. So I have to re-specify the entire exporters, all the options in exporters here. Here, I'm not re-specifying Prometheus. I could have, probably should have. But it's something to note there when you are doing these config merges, is that the maps will merge, but the array elements will be overwritten. And that's just the nature of merging YAML. And you also see several outputs here in my console. That's a load generator hitting this thing all the time. So, okay, I'll put this thing in Honeycomb. What does it look like in Honeycomb? Let me get to a screen there. I'm going to refresh. There it is. Data's coming in. I can click on this. Now I'm going to just say, just give me the traces there. Trace dot parent ID does not exist. That's a fancy way in Honeycomb to say, give me all the roots. I'm going to group this by route and run that query. And we get them all right here. I probably only care about these checkout ones. So I'm just going to filter on checkout right here. And I did that because these are usually the best looking traces that we get out of this whole platform. And you can see it right here. It's called all the different services and all the various stuff and how it works, right? We get span events on these things. This one here has got several span events on it, for example. So receive, get quote, request, processing it. You can see the span events right there. Because this thing came from the front end, it's also got a span link to it. Span link is really just going to give me back a load generator trace that started this off. So you kind of get a sense of what's going on and where. And yeah, we got all the data flowing into Honeycomb. That's pretty cool. It's really easy to get going with that. Now I'm going to stop this Docker one. And we're going to do the same thing again. So the same environment, but in Kubernetes. So just give this a second. This is the CNCF live stream. We love coding. One beautiful thing about coding is sometimes we've got to wait for the things to do their things. And, this is where I need my Jeopardy music.
I really do. I haven't seen any libraries adopt that MP3 while waiting, but fingers crossed that someone's going to implement it soon.
Right? Okay, that's done. What I want to do, starting at that, I want to really kill this. Docker compose down. Just shut it down. Okay, it's been removed. It's gone. EKS, or I have an EKS cluster running already. This is my Helm configuration. Some of you who are familiar with Helm, you can pass in value files when you install a component instead of passing in set and like a bunch of names. I'm going to recommend you do the same thing for vendoring of this. The Helm chart today does not allow you to specify image names. That is on something we're going to do. We're also going to allow you to do resource limits so vendors can get really fancy with perhaps introducing scenarios where maybe you want to add a new feature flag and you want to have a pod crash. So on a memory leak, well, maybe you only get that pod 25 megabytes. So we're going to allow you to do all these things. It will be ready for GA at the end of this month. Not quite there yet. Again, I got to tell this thing my OpenTelemetry configuration. So this is effectively the same config you've seen before, but it's under this OpenTelemetry collector config block instead. And earlier I mentioned there is a small bug. The email service is not exporting its spans. I get over that by passing in this little component to the Helm chart. I'm confident by the end of the week, you will not need to do this. I'm doing it myself because I need to get this out there. I want this to work. So first off, Helm list, I should say nothing here. All right, so Helm install OpenTelemetry demo. This is from the Open-Telemetry, and it's this -demo -values. I'm in the right folder, so I'm just going to call that file already. And this is going to go ahead and install it. I'm going to bring this up a little bit because when it's done installing, it's going to give you that cool little graphic. I don't know who wrote this graphic, but I wanted thumbs up. That is a really hot graphic, by the way. I'm all for ASCII art. Coming from my old days running a BBS, ASCII art was huge back then. So it's installed, it's up and running. I'm going to flip over to this screen here. You can see here all the times here, the ages are very recent. If anybody's wondering, this is a tool called K9s. It is a CLI-based UI for Kubernetes. If you have not heard about it before, I endorse this tool. If not here to tell you to use it, use whatever you're most comfortable with. Absolutely. I love K9s. It's a really great tool. I'll go ahead and search for it. You'll find it's available out there. But it's a great way for you to get operating with Kubernetes. And why did I pull this up as well? Well, I got to port forward some stuff. All this did was just deploy it to Kubernetes, right? As you all know, Kubernetes network is gnarly, as in nothing's exposed unless you explicitly tell it to expose. We pop a bunch of services in here, but they're all cluster IP services. Nothing is done to be exposed externally. If you intend to expose anything externally, it's up to you to then write your own load balanced or ingress, load balance services or ingress routes to take advantage of the existing service, or maybe even deploy additional services to take advantage of it. You would do this above and beyond the standard Helm chart. For vendors, what does this mean to you? Well, you can provide instructions to deploy these things on your own, or you can subchart the Helm chart and deploy them on your own. Up to you how you want to do this and how you want to communicate it to your users, but that's how you would effectively do it if you wanted to provide a way for them to get additional external access. This is a demo though, so I want to be careful on how much we really plan to make this exposed. We do give you simple commands, which is really using the kubectl port forward command to get access to the various pieces of the demo UI should you want to do it on your own. And if you're deploying this to maybe a Minikube, or you got your own EKS cluster running, or AKS or GKE or whatever you got, maybe you're doing something on another platform, it's on you at this point. Mine's running an EKS. And I can absolutely run these commands, but these are blocking commands, and I've got K9s. So I'm just going to come here in K9s and say, hey, front end, Shift F. Yeah, I want port 8080. That's done. That's going to get forwarded for me. I want the feature flag UI. We're going to show off that UI in this kind of here. So in particular, the feature flag UI is running on 8081. Kind of see it right there. So that's the one I want. Let's put that out there. I can expose Jaeger if I wanted to as well. Really all these other things, if you want to expose them, it's all up to you at that point. But I got my front end and my feature flag service exposed for me. So let's go ahead and check them out. I'm going to first go look at the feature flag service. So I've got that bookmarked right here. It's localhost port 8081 is what it's going to be. Oh boy, that's pretty. Wouldn't be a demo if it would work.
That's just how you know it's real.
Oh my goodness. Right. I'm just going to check. Let's look at some logs on this. Feature flag service. I know why it's broken. And this is great. I'm so happy I hit that error. This happens. We're going to fix it. We know about it. We got to do something about it. The feature flag service depends on Postgres. I did a clean deploy. The feature flag service started before Postgres started. And I'm going to go in here and I'm going to see a bunch of SQL errors because, well, yes, Postgres just doesn't have the darn database. How do I fix this? I'm just going to restart the pod. It's that simple. So I'm going to delete it. Kubernetes does its thing. One of the best schedulers in the world. Restarts the pod. This will work. I will need to remap my port forward. This port forward is going to get terminated on me. So I'm just going to re-specify it. And this is how you know it's a live demo. No. Uh-oh. Okay, there we go. It took a second there for it to release a prior forward. So let's try this again. Refresh. Yes. All right. 2 feature flags, product catalog and shipping. This one here is implemented. This one here, not yet. You flip this on, nothing's going to happen. What happens with this one? Well, really, it's meant for a very specific product code, some like OLJ or OJ something product code. If the product catalog service is trying to get that product code, get the details about it, it's going to check the feature flag service first. And if this feature flag comes back as enabled, the product catalog service is going to spit back an error. Awesome, love that. I'm not going to show this off first. Well, actually, let's flip this on. We'll go look at some traces here in a second. So it's on. Oh my goodness, I made errors happen. I'm going to come to Honeycomb real quickly. First, we're going to go back to this little world here. I'm just going to run this query again for the last 10 minutes. You can see here I stopped it in Kubernetes. I restarted it in Kubernetes right there. None of these here will show error equals true, at least not recently, because error equals true is going to be very recent, and they're all right here. These are the ones that now I flipped on that product catalog flag. So when this is going out to go get this product ID, which is randomly selected from a group of like 10 or something like that, the feature flag service will return true. We bubble up the errors all the way up the pipe. This is one of those demo scenarios. So I'm kind of targeting you observability vendors out there in the world. If you want to play around with what does an OpenTelemetry error looks like, we did it for you. This is a great example of it right here of how you can understand what's happening. I believe we also spit out an event here as well to say, hey, we're failing on this because the feature flag was enabled. We do plan on introducing another feature flag, which is going to actually create a latency, potentially even a memory leak. And the hope here is that we will allow vendors to make use of their tools to really discover why it happened. In that case, there it'll be a unique, gnarly little situation where it's a specific user doing a specific thing and causing memory to leak higher. So some fun ways and things to think about. So again, feature flag service is meant for you to enable and disable different kind of usage and demo scenarios. We sometimes call them hero scenarios within the actual platform itself. Now I'm going to show off some code of how we made this all work, how we put this together. I'm not going to show off code for every single service, for every single thing. I kind of want to focus more on the not so popular things, the things that I want people to really focus on when you're running this application, when you're using it yourself. So let me close a couple of these. I'm going to actually start off. We're going to go into the front end service. So the front end service has code to enable telemetry. Of course, it should. It will actually has two tracers part of it. It's got a backend tracer, which is used by the front end's next node service part itself. And it's got a front end tracer used by the browser. I'm going to show off the front end tracer first. See a question here about introducing fault injection. I'm not clear what you mean by that, David. What we're trying to do is we're trying to make it with a feature flag. So if the feature flag returns the fault, then the service itself is just going to explode. It's just going to return an error. Is how we did it. So we're kind of injecting an error based on the feature flag's status, and we're doing that in code. So this here is instrumentation for the front end. It's a little wordier than Node backend. Some of that has to do because we got to do some CORS URL stuff for the web auto instrumentation. We need to kind of wrap things up a little bit more manually. You don't have all the environment variables available to you in the front end, so you got to specify a few more things. When you do this from a back end perspective, you don't need to specify much at all. In fact, this here is not actually, this is the instrumentation for the back end. And then we just wrapped it up with something called backend tracer to make our own APIs easier to use. But this is how you bootstrap the back end. That's it. There's not much to this. And we'll show you the payment service, very similar to this here. How you do it is when you start up the service, you do a required module. So Node is not an agent per se, but required module makes it like an agent. David, your question about chaos monkeys and the tools around that, or chaos engineering, we thought about it. We did. It's kind of a big task. maybe too heavy-handed for what we were trying to do, and we wanted to not have to introduce other dependencies into the stack if possible. So yes, it was thought about, but we were more focused on kind of trying to keep it a little bit more nimble than having to introduce additional dependencies. So this is kind of Node.js. And then from there, what we did is inside the middleware is where we did a lot of kind of magic, if you will. And I want to discuss this because this is where we look at baggage. So baggage is actually added at the load generator level. It'll add a piece of baggage, and all the load generator does is it has this baggage called synthetic request, and they're going to have a value of true. Okay. And here you have to use true string, not true boolean, because baggage is passed in as an HTTP header. It's just a really long string. So everything here comes down back to a string in all the properties and everything else. So we're going to be looking for, we're going to pull baggage out when the request comes in on everything within our API handlers. So this is effectively a Next.js middleware. And we're going to look to see if it's got that baggage. If it does, we are going to effectively create a brand new trace. We're going to stop the existing trace. We're just going to create a brand new span with no prior context. And we're going to put this one into context. We're going to make this one active so it doesn't have a parent effectively. And we're going to link it to the prior span. Note here, span links are really powerful to help you do these things, but you have to specify the span link at span creation time. This is part of the spec. It's across all languages. I've heard people ask, well, I don't know the link until after my span is created. Yes, I get that, but you have to specify it at span creation time because it needs to be mutable. If you need to do bidirectional linking, and then you would have to create an additional span on the kind of the one that you're being linked to initially, and then add the details, the context from that one there. It's going to be a little more manual code. Can be done. I've seen customers do this, but this is basically what you want to do. We're going to add an attribute here, app.synthetic request equals true, because we're going to check that attribute later on. We're not going to check this attribute. We're going to add the baggage header. We're going to push the baggage. We're going to let the baggage continue because we're going to check that baggage later on inside the payment service. So this is kind of how to use baggage, how to make it work. Why we did it in the payment service is I will just show what we kind of did. So the payment service here, and it's kind of charge. Right here, we check baggage again, and if it has a synthetic entry and it is equal to true, we just don't actually charge. We send an attribute to charge or not charge. These are the kinds of things you should be using baggage for. Please, please, please do not use baggage to actually pass context to a downstream service. That's not what it's for. I should say application context or downstream service. You want to pass telemetry context and keep it to that there. Things like synthetic request. So that was kind of getting up and running with Node.js. The front end, I wanted to really discuss that because the front end is unique in that it has two different tracers, one for the browser, one for the Node.js part. The payment service is a pure Node.js only service. And you can see here, this is kind of the idiomatic way of how you spin up and how you add instrumentation, OpenTelemetry instrumentation to your Node service. You will just then do a -- require referencing tracing.js file when you start up your Node application, and boom, you're off to the races. This will instrument most well-known frameworks, though the NPM world for OpenTelemetry is growing rapidly. You could add additional instrumentations to here as well. You'll have to add a little bit of code to do that. A few other things I kind of really wanted to touch hard on here and really make sure everybody kind of got was I wanted to just cover a little bit of the kind of the known things about Ruby in particular. Ruby's different. Ruby's doesn't do gRPC, right? Ruby's different in that area there. So for Ruby in particular, we need to pass in, I'm sorry, I want to pull up the Docker Compose for this instead. We need to pass in the HTTP port to export the traces. So if you're playing with this, you're using this, you're like, why did that happen? That's why. Ruby just doesn't support gRPC for export of its OpenTelemetry data, and therefore we need to specify it that way there. I don't have many other things that are really important I want to make sure people capture. We've documented them all. I should perhaps show some of that documentation. I did not show our service-specific documentation. I think it probably makes sense here as well. But under docs, we have services here. Every service will be documented. They're not all done yet, but we're getting there. For example, the checkout service is probably the most busiest of all services. We go through how to initialize the tracing provider, how to do it right. These are the idiomatic ways to do this, and we do it for every language, for every service. And we show you how we do it. How do we wrap the gRPC calls with auto-instrumentation? How did we take care of the outbound calls? So these are the inbounds and these are the outbounds. How do you get a span? How do you add attributes? What about span events? All that is shown off here. They will all be documented, and as you continue moving forward, because part of the goals of this project is to be well documented, you will see us put them in here. And if we're missing something, please, please, please create an issue. We're going to get to it right away. I'm going to end it there. We're talking quite a bit. If anybody wants to ask any further questions, I'm happy maybe to dive down and show you how we did that.
Awesome. Thank you so much, Pierre. If you do have questions, please feel free to throw them in the chat where you're at, whether it's YouTube, LinkedIn, or or anywhere else that you're watching this. I'm sure that we have some way of getting your feedback. Please feel free to ask those questions, and we'll get those answered. I think one question that I have is, what are some meaningful ways in which we can help kind of contribute back? I'm sure, obviously, being a demo, the biggest thing is going to be testing it and actually like kind of poking at it and really taking a deeper look into some of these different aspects. But is there anything that you think needs a little bit more testing, or really that you're excited to see about this project really coming up?
I would love for people to try this in more scenarios, right? Straight up right now. I would love somebody to stand this up and host it. Let me know how the browser parts work, because CORS is an issue. CORS is a thing. I don't think we've well tested out the whole CORS aspect. And I know once this thing goes on a web browser somewhere out in the wild web world, it's probably going to break. So we'd love to have feedback on that one. I think we need a host. I'm sure others will go ahead and take care of that. But that's the first one. And another one, I made a call out. We're looking for Swift developers. If you can help contribute, I think we've decided not to move forward with Swift for our GA release, but it is something we're going to tackle immediately post GA.
I really like all of the languages that you were able to pick and source around this too, like seeing Rust, C++, Swift, all of those languages. I've done some work in Elixir in the past as well. So really fun to kind of see all those different contexts come together to give you that visibility that you just normally would not get on each of these on their own with each of these languages. So major kudos on that front. That's awesome.
Yeah, major kudos to all the contributors for that as well. We could not have done this without people in the community who knew those languages, were familiar with how to instrument them, and just walked up and said, "Here you go. I rewrote this service for you in that language," and they implemented the proto, and they're off to the races. So it's pretty handy. All right. Did we get any questions on the other various channels, or are we?
No, I think those are all the questions that we have today. So with that,
Awesome.
we'd like to wrap and give you a little bit of time back. But truly, thank you so much, Pierre. Do you have any parting words of wisdom, affirmations, or any fun code snippets to share with us before you go?
Because of this project, I learned as a Python agent. It's interesting when you run into this. I've been part of the OpenTelemetry community for a long time. I had no idea Python had an agent. Although I think the agent was really new when it came out, but it's an auto-instrumenter thing, and it's really handy to use. Please use it if you write Python code. It's really, really easy to use, and we encourage you to try it out. And we also use it for our load generator and everything else. So it's kind of one of those weird things that just happened to me because of this whole project.
Interesting. I didn't know that either. I'd almost want to call it a secret agent, even though I know it doesn't work for any three-letter acronyms.
uh, Python 007, maybe.
uh,
Great.
awesome.
Well, awesome. Thank you so much to CNCF for hosting this live stream. Uh, please join us in Slack. If you're going to be going to the wonderful conference in the month, we are going to have an OpenTelemetry Community Day on the 24th. We're going to be really pumping it up. You'll hear stuff. I'm gonna slip it out. Hopefully Austin doesn't get mad at me, but it'll be called OTel Unplugged. Really excited about this, and I hope to meet you all there in person. It'll be great.
It's going to be fantastic. I can't wait to see you all in Detroit, those of you that will make it. And thank you all for
So I put my
joining.
background right there. That's where we're going to be at the end of the month.
Yay! It's going to be so fun.
Awesome. Thank you, everybody. I appreciate it very much.
Awesome. Thank you, everyone, for joining the latest episode of Cloud Native Live. We enjoyed all of the interactions and questions that you had today. Thanks for joining, and we can't wait to see you again soon. If not online, hopefully at one of the upcoming KubeCons. Thank you very much, everybody. Have a good one.